Hi everyone! Today I will use gallium to make a simple hydrogen generator. This is not a tutorial. Do not repeat anything shown in this video. While gallium isn't toxic, it sticks to everything and it irreparably damages aluminium and its alloys. Hydrogen is a flammable gas that can be explosive in combination with air. Gallium is a soft silvery metal with a melting point of 29.7 degrees Celsius. Its alloys are used in environmentally friendly thermometers, and its compounds are used in electronic components. Gallium arsenide and gallium nitride are some of the most widely used semiconductor materials. Besides having a melting point so low it will melt in your hand, gallium, if pure, will often supercool below its melting point. That is, it will stay liquid at temperatures lower than 29.7 degrees Celsius. This sample I bought years ago stayed partially molten ever since I put its box on a radiator to see how fast it will melt. When gallium solidifies, it does the same thing water does. It expands. Gallium expands by 3.1%. This causes pressure that can shatter a container in which it was stored. The property of gallium that is of most interest to us today is that it diffuses into grain boundaries in aluminium crystal structure. This makes aluminium very weak and brittle. It also disrupts the protective layer of aluminium oxide, so it can react with water similarly to earth alkali metals such as calcium and magnesium. As you can see here, it sticks to glass and forms a perfect mirror. To get started with our hydrogen generator, I took this disassembled two-part CPU heatsink and apply gallium to both aluminium and copper. Gallium doesn't diffuse into copper the same way as it does with aluminium. I did it just to have something to compare the damage to. I also scratched the surface to break the oxide layer. To speed up the diffusion, I put both pieces on a hot plate on a low setting. I also second-guessed myself about the amount of gallium and removed some with a syringe. Here is a sped-up time-lapse of the diffusion. After 2 hours, gallium has spread over the surface of aluminium heatsink and has seeped under the oxide layer. The surface aluminium has already been altered enough it can easily be scraped off. Copper has not changed one bit. If I was doing this experiment with mercury instead of gallium, this would not be the case. My phone battery was low, so I decided to stop recording and let gallium do its thing overnight and at ambient temperature. Overnight, gallium has solidified, but this does not mean the diffusion has stopped. In the morning, I heated the piece to melt and remove the excess gallium. On the sides of the piece, you can see clear discoloration where gallium has infiltrated the aluminium crystal structure. Aluminium was weakened to such an extent I accidentally broke the heatsink when was scraping off gallium. It didn't offer much more resistance when I attempted to crush it to smaller pieces. Interestingly, it was easy to see that the spots on the heatsink further from the point where the diffusion started retained more of its original strength. You can also see gallium in the close-ups of the break surfaces in aluminium. I broke off a small piece of gallium-treated aluminium, put it into a vial and added some water. The reaction was immediate. I caught some of the gas into a test tube and ignited it. Having confirmed I indeed made hydrogen, I scaled up the reaction by breaking up more of the gallium-treated aluminium, stuffing it inside a random dirty soda bottle I found in the garage, and filling it with water to the top. Over the neck of the bottle, I then attached a balloon with which to capture the hydrogen. It is here I encountered a common problem with hydrogen. Namely, its molecules are so small they can easily escape because they can pass straight through the rubber from which the common balloons are made, even speeding up the rate of gas generation, fail to inflate balloon more than you see here. I should have gotten a metal-lined balloon or use another way of collecting hydrogen. Importantly, this would not be a problem if I bubbled hydrogen into a solution or if I built a torch that would continuously burn the produced hydrogen, instead of trying to store it. Indeed, hydrogen can be used for many interesting applications. But who am I kidding? There is but one fate that can befall a hydrogen balloon in my possession. Thank you for your time. Like, subscribe, and if you're new, please check some of my other videos.